Hi. So this video is going to be a follow-up to a previous video that you watched on the very first example in our notes. And that first example really kind of took us through the basics of flow proof. And so this video is going to have different examples of proving triangles congruent and what we can say from that. And so it's going to go at a slightly faster pace. So look at our given, and we're going to start by marking up the picture. So angle E is congruent to angle H. G is the midpoint of EH, which tells me segment EG is congruent to segment GH. And then looking at the picture, I look for what I can assume. I see that I have these vertical angles, so I can state that vertical angle theorem tells me that FGE is congruent to angle IGH. And so now that I have that all marked up, I'm going to go ahead and fill it into my proof. And so in our first, we're already given one that says G is the midpoint of VH. Well, that midpoint actually gave us, and we have to fill in because we don't have enough boxes here. That midpoint, by definition of midpoint, gives us congruent segments. And so then I can say EG, or segment EG, is congruent to segment GH, by definition of a midpoint. There's the side that I need, so I'm taking inventory. Angle FGE is congruent to angle IGH. Well, that is the vertical angle theorem, which tells us that all vertical angles are congruent. There's an angle. And then this missing box would be my other given. Angle E is congruent to angle H. And there's my other angle. And so by angle, side, angle, I have triangles congruent. And I'm done with my proof. So let's look at another example. In example 3, we have JK is parallel to ML. We also have JK is congruent to LM. And so I went ahead and marked that. Looking at this, I also know I have a shared side. So there's my side. And I have my other set of congruent sides from the given. So now looking, I have to figure out what else do I know given this information. Given I have that these lines are parallel, cut by a transversal, I know that the alternate interior angles are congruent. Now notice that the alternate interior angles here are the angles that are formed with the parallel line and the transversal. So many students get confused that these angles are alternate interior, and sometimes they might be, but we don't know because these aren't told to be parallel. So we use the parallel lines as our base for what our angles are going to be. And so let's go ahead and fill in the proof. So given that we have these lines parallel, we know that parallel lines cut by a transversal gives us congruent alternate interior angles. And so then I'm going to go ahead and state that angle JKM is congruent to angle LMK. And so there is my angle. JK segment is congruent to segment LM, which was a given. There's my side. By reflexive property of congruence, I know ML is congruent to ML. There's my other side. Side, angle, side, side, angle, side. So I have all the pieces that I need to keep going with my proof. So by side, angle, side congruence, I can state that triangle JKM is congruent to triangle LMK. But notice that's not what I'm trying to prove. I'm trying to prove that angle J is congruent to angle L. And notice since it's that last box, I know that's what has to go in the proof, but I need to fill in the reason. Well, we know that corresponding parts of congruent triangles are congruent, based on a theorem that we learned previously. So CP/CTC allows us to say that these angles are congruent. In our next example, in our last one for fill-in, we're given that AB is congruent to BC. AC is perpendicular to BD. Well, again, perpendicular gives us right angles, so I'm going to draw my right angle. And then I notice that I have a shared side. And so here I have a side, another side, and an angle. Well, notice that side-side angle is not one of the ways we prove triangles congruent. So then let's look that we have these right angles. Well, if I have these right angles, these have to be right triangles. And notice the only congruence shortcut that we have that explicitly gives us a piece of, or an object in a right angle, is the hypotenuse leg. So in a right triangle, we have hypotenuse. And if the hypotenuse is congruent, if the hypotenuses are congruent, and a leg is congruent, by hypotenuse leg, I can then say that the two triangles are congruent. But I still need to be able to state that I have right triangles. So let's fill in the proof. So again, I know that since this has more boxes, this is going to be my perpendicular because I'm going to need more explanation here. That was given. AB is congruent to BC. That's given. And then reflexive property of congruence tells me that BD is congruent to itself. So let's keep going with our perpendicular. Perpendicular definition says that perpendicular gives me right angles, so I'm going to go ahead and state that triangle ADB and triangle CDB are right angles. Definition of right triangle tells me that triangle ADB and triangle CDB are right angles. Or right triangles, excuse me, are right triangles. So I have to say that I have a right triangle in order to have my congruent hypotenuse and then my congruent leg. So then by hypotenuse leg congruency, I can state that the triangles ABD is congruent to triangle CBD.